My name is Kevin Solberg, and I'm the project manager and data specialist for the Mapping Prejudice project. And I'm going to talk about our specific methodology and how we're using a whole host of different digital tools to build the first comprehensive spatial database of racial covenants for a major American city. Our project begins with physical analog warranty deeds. These were the property records that were recorded at the Hennepin County Recorder's Office. We take these deeds and push them through something called optical character recognition. This allows us to partially automate the process of identifying racial language. So a little bit of background and a little bit of context. Between 1900 and 1960, over 2.4 million property records were recorded at the county level. I did some math, and assuming I can read more quickly than I actually can, just to read through the entirety of these documents, spending 40 hours a week, it would take me over 2 decades. And this problem, this logistical problem, is the primary reason why no other city has ever built a map like this. Traditional research methodologies just are not up to the task for dealing with data that's so large and so dispersed. So what we're doing is using something called OCR, or optical character recognition. Essentially, OCR is taking an image of text. So imagine if I took out my cell phone and took a picture of one of these warranty deeds and uploaded that picture to a computer. The computer views this as a picture. The computer can't read that. But if you take an image like that and push it through an OCR engine, what comes out is a text translation. Think of it as a Word document. So what we've done, and we've done this using the Google Tesseract OCR engine, is take millions and millions of these digitized property records, push them through the Tesseract OCR engine, and what comes out is millions and millions of text translations of these deeds. Once I have a text version of each one of these documents, I can write another script that looks for certain language. We're looking for terms like Caucasian, race, Negro, Mongolian, Asiatic. These are the terms that we have found in racial covenants thus far. And we tell the computer to flag all the OCR translations looking for these individual terms. If there is a term, if it does match one of these predefined words, set that image aside. And by doing this, we're able to narrow down millions and millions of records into tens of thousands of records. However, there's still more work to be done. It's one thing to have a stack of deeds that we believe contain racial language. It's another thing to have spatial data that I can actually map. To do this, we are using the crowdsourcing platform called Zooniverse. And essentially, if you go to our website at mappingprejudice.org and click Get Involved, it will take you to this online portal. And what you'll see is a random deed that will be outlined in red that denotes a deed that we believe contains racial language. This is one of the images that the computer flagged during the OCR process. And we ask volunteers to read these images and answer a few questions. We're asking questions like, who bought the deed? Or who bought the property and who sold the property? At what date was this deed recorded? What's the edition name, the block number, and the lot number? Those last 3 are very important. That's what gives me enough spatial information to actually build this database. So what happens as volunteers go onto our Zooniverse portal and start answering these questions, they get compiled into an attributable database, which looks something like this. Essentially, every value that you see in here, this is a value that an individual volunteer typed into our website. And once I can get the data into a form that looks like this gives me enough information to actually build the map. The next step is connecting this attribute information that we've derived from Zooniverse to real-life spatial location. And to do that, we're using something called a shapefile. We're using the 2010 Hennepin County Parcels shapefile to be precise. Essentially, this is a map that has a polygon depicting every lot in the city. The problem is that many covenants went into place in the first half of the 20th century. A lot of these lots no longer exist. What was once a neighborhood might now be a freeway. So part of our process is identifying the lots where the spatial boundaries have changed, and that's what you're seeing behind me. The blue polygons, this denote all the lots that currently exist in the parcel shapefile. The red polygons are all the lots that exist in the shapefile that haven't changed since they were initially platted. And you'll notice there's a fair amount of blank space there. We have to use historic plat maps and reference materials to fill those blanks in so we can connect this spatial database to the attributable database. Through this process, we have mapped over 6,000 racial covenants in Minneapolis thus far, but we've identified many thousands more. There are currently about 10,000 additional warranty deeds on Zooniverse that are being annotated and transcribed by our volunteers, and we anticipate finding between 5,000 and 10,000 more racial covenants as the optical character recognition process completes. About 40% of these restrictions will be located in Minneapolis. The reason I have to be a little bit approximate about that number is that property records are actually recorded at the county instead of the municipal level. What this means is that there's no way for us to preemptively only look at warranty deeds logged in Minneapolis. We have to look at the entirety of the county. Essentially, this means we are building a database of all the racial covenants for the entirety of Hennepin County. We're just choosing to map the Minneapolis restrictions first. And as you can see, this requires a tremendous amount of effort, and we have had to clear some pretty significant technical hurdles in order to translate these analog warranty deeds into mappable data. And next, I want to talk about why we're doing this and what we've found so far, and what we hope to achieve by the end of this project.